right, welcome to the reteaching of the slopes of parallel and perpendicular lines. If lines are parallel, like our purple and green lines here, then their slopes are the same. They are rising and running at the same rate. Rise, run. They're going up 3 to the right 5, up 3 to the right 5. Okay, they're exactly the same. Okay, parallel lines, they never intersect, so they don't touch. Now for perpendicular, their slopes are negative reciprocals. So my green line and purple line, they intersect, but they have to intersect at that 90-degree angle. So the relationship between the perpendicular lines is that they're negative reciprocals. So the slope of my green line is down 6 to the right 7. So the rise over run is down 6 to the right 7. To get the reciprocal, we're going to flip the numerator and denominator. So that's why the purple line is flipped, 7 over 6. And then we change the sign. If the green one is negative, then the purple one has to be positive. Okay, that's going to be one of the ways that they intersect. Okay, so perpendicular lines have negative reciprocal slopes. So we flip the numerator and denominator, and then we take the opposite sign. All right, what is the slope of the line perpendicular to the line whose equation is 9x minus 6y equals 36? Fully simplify your answer. So our key word here is going to be perpendicular. Why? Because that tells us we need the negative reciprocal. The negative reciprocal of our slope. Okay? Now this equation is 9x minus 6y equals 36. This is in standard form. ax plus by equal to c. That's standard form of the equation. I do not have the slope in standard form. In order to see the slope, I need to change it into y equals mx plus b form. This is the slope-intercept form. And the way I do that is I'm going to take this equation and solve for y. So I'm going to take the 9x minus 6y equals 36, and I'm going to solve for the y variable here, which means I need to move my x term. So I'm going to subtract 9x from both sides. That's going to eliminate it from the left. I'm left with negative 6y equals that negative 9x is going to come first because the x term comes first in the slope-intercept. And then the 36 is positive. It's going to be plus 36. Then I'm going to divide by negative 6 because I still need to solve for y. Negative 6, that cancels out. And now I get y equals, and I get negative 9 over negative 6. That's going to turn that double negative into a positive. And they're both divisible by 3. So that's going to simplify to 3 over 2. X, and then 36 divided by negative 6 is going to be negative 6. Now what I really need from here is the slope. And it's got to be perpendicular. So I need to take that slope, flip it. So 2 over 3. This slope was positive, so this slope needs to be negative. So my answer is going to be negative 2 over 3. That is the slope of the line perpendicular to the line whose equation is 9x minus 6y equals 36. And I did fully simplify my answer because 2 and 3 are both prime numbers and I can't divide out anything else. Okay, so just to recap, it was in standard form. I don't have my slope variable in standard form. I have to change it into slope-intercept form where I have my slope. To do that, we solve for y. So I move my x term, and I divide by the number in front of y. I simplified my terms, and then I took the negative reciprocal of that slope. My new slope is negative 2 over 3. What is the slope of a line perpendicular? So there's my keyword, perpendicular. That's going to be the negative reciprocal of a line whose equation is x plus 3y equals negative 15. Fully simplify our answer. So again, I don't have my slope in this form, so I need to change it to y equals. So to do that, I need to move my x term. That's going to cancel. I get 3y equals negative x minus 15. I'm going to divide by 3. That'll cancel out. Y equals negative. Now, I don't have a number in front of the x, but there is a number there. We just don't always write it. It's a 1, so it's going to be negative 1 over 3x minus 5. And I need this negative 1 over 3 because I need to change it to the negative reciprocal. So I'm going to flip it. That's going to give me 3 over 1. This is negative, then this one has to be positive. And to further simplify it, 3 over 1 is just 3. So my slope here is just going to be 3. What is the slope of a line parallel to the line whose equation is 9x plus 3y equals negative 27? Fully simplify your answer. Ooh, here our keyword is parallel. That means we're going to have the same slope. So again, this is in standard form, and I don't know what my slope is in standard form. I have to change it to y-intercept. So I'm going to solve for y. I'm going to get this y term by itself. So I'm going to subtract the x term, subtract 9x. That's going to cancel, and it's going to leave me 3y equals that negative 9x minus 27. And then I still need to solve for y by dividing by 3. So I'm going to divide by 3. And y is going to equal negative 3x minus 9. And again, I want to focus on the slope. So now my slope is negative 3, which means my new slope is going to be negative 3. So negative 3, they're going to be the same. We have the exact same slope. What is the slope of a line parallel to the line whose equation is 5x minus y equals negative 9? Fully simplify your answer. Our keyword here is still parallel, so that means they're going to be the same. And again, my equation is in standard form. I need to get it into slope-intercept form, so I'm going to subtract my x term minus 5x from both sides. I'm left with negative y equals negative 5x minus 9. I do have a number in front of y. It's going to be a negative 1, so I'm going to divide by negative 1. And I get y equals 5x plus 9. Again, I want to focus on the slope. My slope is in front of the x term. That's going to be 5. So my new slope is going to be 5. Okay, the lines represented by the equations 9y plus 15x equals negative 63 and y plus 5/3 x equals 9 are neither parallel nor perpendicular, parallel, perpendicular, or the same line. All right, so we know if they're parallel, they're going to have the same slope. We know if they're perpendicular, they're going to have negative reciprocal slopes. If they're the same line, then the equations are equal. Okay, the equations are equal. So we got to double check and make sure our equations have different y-intercepts. And if neither one of these apply, then it's going to be neither parallel nor perpendicular. So if I look at my equations, this one's not quite in standard form. These two are switched. We're still going to solve for y. Here, again, they're not quite standard form, but we're still going to solve for y. So I'm going to start with 9y plus 15x equals negative 63. I'm going to subtract, nope, I don't want that one. I want the x term. So I want to subtract the 15x from both sides. That'll cancel. I get 9y equals negative 15x minus 63. And then I want to divide by 9. Everybody gets divided by 9. Y is going to equal 15 divided by 9. They're both divisible by 3. That's going to give me negative 5 over 3x minus 63 divided by 9 is 7. So here's my first equation that I need to compare. Second equation, y plus 5/3 x equals 9. Then I need to solve for y, so I'm going to subtract that 5/3 x from both sides. And I get y equals negative 5/3 x plus 9. All right, so now what I want to do is I want to compare the slopes. I want to look at the slopes. Negative 5/3 and negative 5/3. Okay, well that tells me they're the same. So we're either looking at parallel or the same line. So how do I tell which one's which? These need to be different. If these are different, then they are parallel. If they were exactly the same, then it would be the same line. Okay, so in this case, these are going to be parallel because they have the same slope and because the y-intercepts are different. I have a negative 7 y-intercept and a positive 9 intercept. That makes them parallel. Okay, we have the lines represented by the equations 18y plus 15x equals 54 and 5y minus 6x equals negative 40. So neither one of these are in slope-intercept form, so we're going to solve for y. I'm going to start with 18y plus 15x equals 54. I'm going to subtract 15x from both sides. I'm going to get 18y equals negative 15x plus 54. 54 is positive, and then I'm going to divide by 18. Okay, these are both divisible by 3, so y equals negative 5 over 9. 18 divided by, nope, 6. X and 54 divided by 18 is 3. So I get negative 5/6x plus 3. For the second equation, I'm going to add 6x to both sides. So I get 5y equals 6x minus 40. Then I'm going to divide by 5 on both sides. And I get y equals 6 over 5 minus 8. Forgot my x. Okay, so again, I want to compare my slopes. I have negative 5/6 and 6 over 5. So I could tell they are not the same. So that's going to knock off the parallel in the same line. But I need to check and see if they are negative reciprocals of each other. So if I flip this one, I do get the 6 over 5. This one is negative, this one should be positive. So these are going to be perpendicular based on their slopes. All right, now it's your turn to show me you can do this.